Hello, everyone. How are you? We are here together with Marcelo today in order to talk about some topics that you already know. We are gonna be talking about GraphRAG on AWS, um, and then some of the things that we're gonna be discussing: how to improve the standard RAG, how to boost precision and context with graphs, and how to run it on AWS with Bedrock and Neptune. I'm going to be sharing a link with you so you can contact afterwards Marcelo in order to share your ideas or anything that you need in order to run your project. So, being said that, Marcelo, please go ahead.
Okay, thank you, Andres. Welcome, everyone, and thank you for joining. Today, we will explore how we can move from traditional RAG to graph RAG. This is a new way to get deeper insights from your data. We'll see how graphs add structure and context that normal RAG cannot capture. At the end, we are going to show you a real example using a public data set to demonstrate this difference in action. Okay, here's our plan for today. We will start with a quick overview on RAG, then we will explain what GraphRAG is and why it matters. After that, we will see a demo using real emails from the Enron dataset. We'll discuss why the answers differ so much between both approaches, and then we will wrap up with some conclusions and your questions, of course. Okay, what is RAG? RAG stands for Retrieval Augmented Generation. It works by taking your question, searching for text that looks similar, and sending those fragments to a language model to create an answer. This is super oversimplified. This works very well when the answer is in one clear paragraph. For example, when we ask for a date, name, or a single definition, or something that can be easily found in different fragments of text. But RAG has limits. It can miss parts of the answer that are in different documents, or perhaps they are written in different ways, and it also cannot connect dots. So if something is spread across multiple emails or multiple documents, RAG just won't know how to link all these little pieces together. GraphRAG is going to change this situation. If RAG is like reading a book one paragraph at a time, GraphRAG is like drawing the story's character map where you see who is connected to whom. So instead of only working with chunks of text, it will extract entities. That can be persons, companies, places, and the relationships that they have between them. It will then build a knowledge graph. So you can think of a graph as a network of dots that is connected by lines, where each dot is an entity and each line is a relationship. With this structure, the AI can reason across multiple connections. In AWS, we can build this easily using Bedrock to extract entities and facts. And Neptune, which is a graph database that AWS has, we use it to store and to query this graph. GraphRAG is useful wherever we need to connect data points that are not clearly related. For example, in finance, it can reveal hidden relationships between companies or people involved in transactions. In legal or research contexts, it helps find links between cases or studies that share key concepts but can use different words. Its main value is that it finds what is not obvious. Now we are going to see this in action. I'm going to switch to the AWS console to show you a real implementation of GraphRAG using the Enron dataset. For the demo, we are going to use this Enron email dataset. For those of you who are young, this is a public collection with hundreds of thousands of emails, but we will look only the ones sent by one person, which are about 600 messages. Enron was a very big energy company in the United States that went bankrupt in the early 2000s after a fraud scandal. So that's why we have all this data set with all these emails that are now of public domain. Okay, I will switch to the console. We go to Amazon Bedrock, and then in Amazon Bedrock, we go to knowledge bases. For this, I have already created a couple of knowledge bases, and they are taking the information from an S3 where I loaded all these emails. I'm going to show it here. This is the data source. Where we have all the emails that were sent by this person. These are about 600 emails. So all these documents, they serve as, I will open one just so you can see how it looks like. Okay, as you can see, it's just an email with the header and the subject and the body. This is for all the 600 emails that this person sent. Okay, so this I use this as a data source for both RAG, normal RAG knowledge base, and also a GraphRAG knowledge base. This is the one that I only use the standard vector storage. We are using S3 vector storage here, and we can ask the same questions to both knowledge bases to see what's the difference. For instance, I'm going to ask if this person sent personal emails. Okay, the normal RAG implementation finds that yes, he has sent emails and he is quoting one source because it looked only on one document where it found that he sent emails from his personal Hotmail account to his work address. So let's see what happens when we use GraphRAG. Okay, the answer here is pretty much the same. So perhaps there isn't much to see here. So let's try to go deeper now. I'm going to ask what personal emails did he send? Okay, he detected an email from Lucy Gonzalez and another survey-related messages to Tori something. And as you can see here, it looked at 4 sources. So we are going to ask the same here to the GraphRAG. So he found the same to Lucy, and he found something else. He found emails to a couple of more addresses. Okay, so we are already seeing that GraphRAG, even if the data source is the same, is finding more information that for RAG was, let's say, invisible. We're going to ask if any of the communications indicate fraud. RAG could not find anything, and it codes 5 sources. Okay, GraphRAG says the same, but as you can see here, it looked at much more documents this time. So the search was more thorough. Okay, so we can keep asking different questions, but I think you get the idea of what's the difference here, where it doesn't go to the first result that it finds, semantically similar as in RAG, but here it goes to what's similar and what's connected to that. And then it goes some more hopes along the line to keep finding information and gives all that context to the LLMs so you can get the answer that you're getting here. So, okay, as we're going to explain a little bit more of what we saw. The RAG model did fine with direct searches. It could find some emails that he sent from his Hotmail account and messages that he forwarded. But that's it. It only looked at text fragments, so it couldn't connect who was writing to whom or when those patterns happened. And with GraphRAG, on the other hand, we have a network to visualize. So it found not only the emails, but also connections between the senders and recipients, including personal addresses that were not included in the RAG search, like this Mo Shuffle at hotmail.com. It even identified that some messages mentioned others indirectly, showing social links that were hidden in the first try. Okay, we already saw this in detail. So why are these answers so different? We mentioned a little bit about this because this is because of what each approach is using to feed the language model. RAG gives the LLM isolated text chunks. GraphRAG gives it a structure map of relationships. You can think it like RAG fits the model random paragraphs. GraphRAG fits an organized network. So the reasoning still happens in the LLM. As you see here, when we choose this test window, we have to select here what we are going to use for the response generation. Here we chose Claude Sonnet as a model. This is the one that is getting the information from the database and putting together this answer that you can see here. Okay, so the difference is the data that the LLM is getting. So it can reason better with better data. That is why GraphRAG can connect to Philip Allen, talk to Lucy, and Lucy also talk to another person, while RAG only sees Philip sent an email to Lucy. Here we can visualize how this graph that is made in this Neptune database will look like, where from Philip we can extract all these entities, which is work email, work contacts, personal emails, the contacts, Lucy, Jim, and Mo, and how they are connected. So, in conclusion, RAG is perfect when you want a simple answer fast. GraphRAG is better when you need the LLM to understand context and relationships. So, to be clear, GraphRAG doesn't think by itself. What it does is organize the information in a way that helps the model to think better. And they are not competitors. It's not like RAG is better than GraphRAG or GraphRAG is always better than RAG. And they complement each other. So if you want to build a good application or a strong AI system, perhaps you have to combine them both, RAG for retrieval and GraphRAG for structured content. I don't know, Andres, if we have any questions.
Yes, thank you very much, Marcelo. Yes, we have a couple of questions
Okay.
here. The first one, how could GraphRAG help detect early warning signs of insider trading of data leaks in corporate emails?
Okay, this is a great question because this is a great way where GraphRAG can be implemented. GraphRAG can reveal hidden communication patterns. For example, when someone suddenly starts emailing new external contacts or forwarding sensitive information outside the company, because it tracks entities and their relationships over time. So it can flag unusual connections or behaviors that normal text search wouldn't notice. So it's not about reading private content. So it's about spotting these abnormal interaction patterns in the graph.
Okay, thank you. Another one, what privacy and ethical concerns arise when using public datasets like Enrons to train or test AI?
Okay, this data set is special because it became public through a legal process, but it still contains personal information. So when we use it, we need to be very clear that it is for research and for testing. This is not for profiling individuals. The main ethical challenge we have is protecting privacy while still learning from real data. That's why modern systems anonymize names, remove sensitive content, and follow strict data governance rules. So you need to have prior to training this or to getting this information to the graph, you need to establish a pipeline where you can clear the information and make it ready for it.
Excellent. There's an additional one, Marcelo.
Okay.
Could GraphRAG be used to map the social graph inside a company and find hidden influencers?
Yeah, of course. GraphRAG can show how people actually communicate, who is sharing information, who is connecting teams, who is acting as a bridge between departments. Um, and this doesn't always have to match the organizational chart. So it can help managers to understand informal influence and collaboration. But of course, this should be used ethically, with transparency and with consent, especially if it involves communications, internal communications, or that sometimes can have a personal or a private element, as we saw in the emails.
Okay, another one, Marcelo.
Okay.
Someone asked if you can describe the most powerful implementations you did with Graph, yeah, that you were working on, or maybe some that you saw. I don't know, a powerful implementation with
Okay,
Graph.
yeah, there are some great examples for AML and for fraud detection and for risk assessment, where you can find these hidden relationships between people or companies that are not obvious. For instance, if you can be onboarding a company, and when you get that company and you ask about that company to a normal RAG, it can perhaps shield no results, but if you query this new data of this person, a new person that you're onboarding, to a GraphRAG implementation, perhaps you can find that this person is related to someone that has some problems, that or has raised some flags or shares something that is not obvious, like they share the address of something that has some problems, things that you can only discover if you go deeper a couple of layers in the information that you have. And with this, you can do it automatically.
Great. I think we are done. I don't know if you have something additional to comment, Marcelo.
No, I think that's it. Thank you all for your time today. So I hope this gives you a clear picture of how GraphRAG can take us beyond the just a retrieval into real understanding of your documents and your data. If you'd like to explore more about how GraphRAG can help your business or could fit in your data architecture, we are happy to discuss this. So feel free to reach out and to contact us. So thanks again and see you next time.
Thank you very much. Thank you all. See you soon.